Today's topic comes to you from section 8.5, and the main topic is what's that word? That's right, trapezoids. Thank you. Okay, there are two aspects to trapezoids that we're going to talk about today. So we're doing MA 912GR.1.5. Okay, so listen to this. There are two approaches, two aspects to trapezoids that we're going to look at. One dealing with angles, the other one dealing with midsegments, lengths of the midsegment. And today, right now, this second, our objective is this, and I'm going to make it very student-friendly, very to the point, shortcut as humanly possible. I can use, some of you don't even have to look, you could just listen to my words. I can use the mid-segment theorem to find specified lengths in a trapezoid. Now again, if you don't end up copying this or you're missing something, this will be uploaded into Google Classroom. So today we're going to be using the midsegment theorem to find specified lengths in a trapezoid. So the overarching or overarching? Whatever. Anyway, the main topic is the trapezoid. So before we get into the actual steps on how to do this, I want to talk to you about what a trapezoid is and the anatomy and physiology of a trapezoid. So the discussion starts like this. What is a trapezoid? That's the essential question. Well, a trapezoid is nothing more than a quadrilateral that has at least one pair of parallel sides. So if that's my trapezoid, it's got to have one pair of parallel sides. Now, if you had to take a guess, which sides do you think are parallel? The left side and the right side, or the top and the bottom? Just in your opinion. The top and bottom is correct, just by the looks of it, because when we think of parallel, we think of two lines that lie in the same plane and never intersect. If you extended this line forever and ever and this line forever and ever, they would touch. But this and this top and bottom will not touch. They are the parallel sides. To clear all this up, we use a symbol in math where we put an arrow on the parallel lines. Now, if I had two arrows here and one arrow here, they're no longer parallel. But if I had two here and two here, guess what? That's parallel. Any questions with that? No. Okay. So in the trapezoid, we have to have at least one pair of parallel sides. And the non-parallel sides, like the left side and the right side, those are called legs. That's a leg. That's a leg. That's a leg. That's a leg. The sides that are parallel, they have a name. Do you know what they're called? They're the bases. I'm going to put base. You got two bases. That's a base, and then the bottom is a base. And to distinguish between the two bases, maybe we'll call the top base 1 with a little subscript 1, and then maybe this is right here, base 2. Any questions between the bases and the legs? Okay, so that's the first thing I want to talk to you about. Now, supposing I call this point A and I call this point B. Instead of saying this side, that side, the top, the bottom. Supposing I call this side right here D and this side C. Now here's a probing question this is a probing question. If I ask you, which two sides are parallel? What would you say? Would anyone like to answer that? If I said to you, in this trapezoid, which two sides are parallel? Which would you say? Say what? Yeah, the bases are parallel. Now, to make that statement, what I'm trying to get at is, how do you name this base and how do you name that base? And you would just say something like this, just so you sound professional and correct and appropriate. You would say, since the endpoints are A and B, but you have to put a line segment over that. And you have to say line segment AB is parallel to line segment what? CD. DC, CD, same. Perfect. You'd say, I just want to make the statement that line segment AB is parallel to line segment DC. That's the name of this line segment. DC is the name of that line segment. If I said to you, give me the name of one of the legs, can you tell me one of the legs? The name of one of the legs? Anybody? Line segment what? Ooh, one leg is legs. Line segment BC is a good response. And what's the other leg? Yeah, I like that. You're saying line segment AD. I just want you to be able to speak this properly. Now, any questions with that? Okay, I'm going to move on step by step. I'm not biting off too much today. So here's what I want to talk to you about. Remember, our goal is something called the midsegment theorem. So now that we know almost everything about a trapezoid, let's talk about the midsegment. You ready? You ready? You ready? You ready? It goes like this. Yeah, I'm going to draw another trapezoid just to keep it kind of neat. If I had this trapezoid right here, there's a trapezoid. If I said this is parallel to this, and then I call this, just say, I'm just writing this down because I'm going to ask you a question about this. If I said that's a trapezoid because the two bases are parallel, can I ask you a question? What do you see this point right there? And those two those little hash marks there, the tick marks and two tick marks. What do you think those two tick marks indicate here and here? If I drew the line segment, this leg, and I put 2 marks here and 2 marks here, what do you think that indicates? That what? No, say it. Say what you said. Listen, exactly right. That means that this segment is congruent to this segment, which makes that the midpoint. Definition midpoint bisects the segment into two. So guess what? That's the midpoint. That's why I put these two little marks here and here. Look at this. This segment has 1 mark, and this segment has 1 mark. What does that make this point? The midpoint. Any questions with that? Because guess what? If you ever connect the midpoint of one leg to the midpoint of the other leg, that line right there, we know this is a base. Let's call it base 1. We know that's base 2. But if you ever connect the midpoints of the legs, just like that, that has a name. It's called a mid-segment, right there. And I just want you to know that if I had to put a plain, in regular plain old English, the mid-segment of a trapezoid, what's the main concept of a mid-segment? It's a segment that connects the midpoints of the legs. There you go. There it is in words. There it is in picture form. A midsegment connects the midpoints of the legs. That's all it is. And if you understand these concepts before I start, you're going to have an amazing time doing this. Are you copying that? And if you don't get it copied, where can you find this video? SIS. I'm going to load it. Okay, so now, so don't feel like you got to rush if you miss something. As a matter of fact, before you leave, if you want, I could make you a copy. I'll put this through my printer and make you a copy of the notes. Now, but I do want you to copy. Here is the big deal of the day. Are you ready? Y'all ready for this? I'm going to start by giving you an example. And the example is going to be find CD. What does it mean when you have two vertices next to each other? It doesn't mean line segment. It doesn't mean line. It doesn't mean ray. It doesn't mean anything but what? When there's nothing above it? Say what? It's the distance from C to D. And what if I said the question is find CD, and what if I gave you, now this is going to take a minute, but what if I gave you this? I'm going to give you a trapezoid. You draw it. It doesn't have to be perfect. Trust me. There ain't nothing perfect about the way I draw. And what if I called this point A, point B? And what if I put this in here? Point C, point D. And finally, point E and point F. And I said, find CD. Now, I'm just going to tell you, this is 12. The distance from A to B is 12. The distance from E to F is 30. And it says, find CD. There you go. Concept number one. In order to do this problem, you would have to recognize that that is the midpoint at point C of this leg, AE. D is the midpoint of BF. So I'm connecting the midpoints of those two legs. That is a mid-segment. And we're looking for CD. So you know what I'm going to do? I'm just going to call CD X to make it simple. Because I'm just going to say find X. That's the mid-segment. So to me, finding the mid-segment, here it is. The first thing I would do is write down the mid-segment theorem. Whenever you think of a theorem in math, a theorem is nothing more than an equation. Like the Pythagorean theorem, a squared plus b squared equals c squared. All the theorems are just equations. So the mid-segment theorem is this. This is the mid-segment theorem. So you know, I'll put a star. Mid-segment theorem, if I could spell properly. The mid-segment theorem goes like this. The mid-segment, I'm going to abbreviate this, mid-segment equals this mid-segment right here. CD. You see CD right there? That mid-segment is nothing more than the average of the two bases. Remember, I'm going to call this base 1. So base 1 equals 12. I'm going to call this base 2. So base 2. And what does base 2 equal? 30. And this is the theorem. The mid-segment equals the average of the two bases. Now, when you average two numbers, you just add the two numbers together. That means base 1 plus base 2 and divide by 2 because there's two numbers you're adding. That's it. That's the big deal. So you write down the mid-segment theorem and then you substitute. Do you have a value for the mid-segment? Well, look at the midsegment. What is it? You can put CD for the midsegment, or I simplified it. What did I call the midsegment? And the class said X, because that's the midsegment. And what does X equal? Make a substitution for base 1. So what am I going to write there? Because I'm talking about base 1 plus base 12. What is base 1? Let's take a look. What number do I put there? Yep, thank you for that. Plus base 2, 30 over 2. Don't be sad. Don't be depressed. We're going to use a calculator for that. We're just going to go, uh-oh, everyone sees that. Yeah, right, okay. 12 plus 30 equals 42 divided by 2. Just let the calculator do all the work. So guess what? X equals what? 21. And that is the final answer. Any questions with that? So 12 plus 30 is 42. Divided by 2 is 21. Now, kids, that was one example. Let me step it up. I'm going to show you example 2, and I'm done, and I'll release you. I'm not going to teach you to death, and so you have blood coming out of your eyes from being bored to death. You ready? Example 2. I'm going to turn a page. Example 2. I'm going to change the complexity level and the difficulty level, but it's okay because I'm going to work with you. I might say something like this. Find YZ. Then I'm going to give you a trapezoid. And the trapezoid will look like this. I'm just making this up. So I got a trapezoid. And if it's a trapezoid, I'm going to say this is parallel to that. I'm going to call this point P. I'll call this point Q. I'm just writing this down. Okay, I'll call this Y. Call this Z. Somebody give me a letter for that. Okay, good. S. Thank you. Someone give me a letter for that. Okay, good. R. Now, I'm going to tell you that this side right here is going to be X plus 14. I'm going to say that this segment right here is going to be 5X minus 19. And I'm going to just make up a number. Someone give me a number. Excellent. 38. Love it. Can you see it? Can you see it? Can you see it? Y'all see it? So, again, you're going to be able to view this tonight. Right after school. You go home and watch this for excitement. Yay. But listen very carefully. Can this be called the midsegment? Well, is that the midpoint of PS? It is, because you got 2 marks here, 2 marks here, so that's a midpoint. Is Z the midpoint of QR? It is. So since YZ connects the midpoints, it is the midsegment. The only thing I could ask you to do is step 1. Write down the midsegment formula. And this is leveled work now. This is EOC level. We are going to write down the midsegment formula. So mid segment This is the general theorem. It equals base 1 plus base 2 over 2. That never changes. Now, question. Once I write the midsegment theorem, substitute. What do you think the midsegment's going to be? Is it 38? Is it 5x minus 19? Or is it x plus 14? Thank you for that. The midsegment's right there. It is 5x minus 19. And that equals, what do you think base 1 is? Okay, if you want to call this base 1, call it base 1. If you want to call it base 2, call it base 2. What would the name of this base be right here? Okay, so call it base 2. Hold your question, because I know what it's going to be. I'll answer it in a minute, I promise you. I'm not ignoring you. But in the course of this, you may hear the answer. So I got to plug in base 1. We look right here, and we said base 1 is what? Okay, so right here when it says base 1, we're going to put 38. Drop the plus sign, and what's base 2 going to be? Yeah, it's just going to be x plus 14. It's not a nice, neat number, constant, but nevertheless. And we have, remember, the midsegment is the average of the two bases, so divide that by 2 and solve. But if you want my opinion as your teacher, when you solve, this is another complexity that you'll learn. If you're not good at solving equations, I'm going to help you. But what I always tell students to do is simplify both sides. Like, that's a variable term and a constant term. You can't add or subtract that. They're not like terms. So just write it down. That's just going to be 5x minus 19. But on the right side, up in the numerator, you have 3 terms. You have 2 constant terms and 1 variable term. You can add the constant terms. So I drop down the variable term, which is just x. And I know 38 plus 14, which is going to be, that's right, class, 52. You better check me because I used my brain. And, whew. What do I have to put this over? It's 2. Don't forget your 2 there. So all I did was I collected like terms. I put 38 and 14. Bless you. Okay. Now, if I'm going to do this one way, but there's so many ways of solving this. Please don't get confused. If you have your way and you're good, then go do what you do. But one way is when you have this fraction with a 2 under it, it's possible to put a line under this and put a 1. And now it just looks like a ratio set equal to a ratio, which is proportion. But so help me, promise me, whenever you have terms that are adding or subtracting, you put a parenthesis around. Parenthesis, parenthesis, parenthesis. Cross multiply. Like cross multiply these two. When I cross multiply these two, I put a 1 in front and I multiply the 2 times the 1. So it looks like this. 2, open parentheses, 5x minus 19. And I drop my equal sign and I multiply these. Well, there's a 1 in front of here, so what's 1 times 1? Yeah, so it's like 1 times x plus 52. And I got to solve, oh my gosh. When I solve this, and I got to, order of operations, do what's inside the parentheses, but not like terms. But see the 2 in the parentheses, and there's nothing in between? That means times. And you have to use what they call what property am I using? Begins with the letter D. Distributive property of multiplication over subtraction. So I say 2 times 5x is what? Then when I take the positive 2 times just look at that as a negative 19, positive times negative is minus. Now, if you don't know 2 times 19, grab your calculator. What is 2 times 19? Oh my God, for real? Sorry, go ahead. 38. Thank you for that. Now, 1 times anything. 1 times x is just x, and 1 times 52 is just 52. And most of you kids are as good or better at solving this than I am. I look at the right side and I remove the variable term. Inverse operation, x minus x cancels, but so help me, put minus x on this side. Now what's 10x's take away 1x? Wait, what's 10x take away 1x? 9x. That's right. Drop the minus, drop the 38, drop the equals. Those cancel. That means they add up to be 0. And that equals what's left is 52. Now, what are you going to remove from the left side? Yeah, how do you do that? Yeah, you're going to add. Add. Whatever you do to one side, do the same thing to the other side. Those cancel. So you're left with 9x's equals, what's that going to be? 90. And the last step is to do what? Divide by 9 here. Divide by 9 here. 9 divided by 9 is 1. When I say they cancel, cancel has 2 meanings. One, they either add up to be 0, or the other version of cancel is like they divide and become 1. 9 divided by 9 becomes 1, and 1 times x is just x. And 90 divided by 9 is 10. Yay! Am I done? Yeah. Wait a minute. Someone said no. Someone said yeah. Am I done? Okay, well, let's see if you're right. We got to go back. We got to go back to the question. It says find yz. We found x. Are we done? Because they didn't say find x. We did 6,000 years worth of work, and we're not even done. But if you find x, and it's not what they're looking for, but you have to find x, this has a name. It's called an input what? Yeah, sometimes your kids call them plug-in values. We needed x. You had to find x. So you go back to the question. Now, I'm going to just write the fact that, hey, so I don't have to keep looking at the bottom of the page. Guess what x equals? Okay, just... Now, if it says find yz, you're like, okay, what's the distance from y to z? Let's start at y and go to z. What do you think the distance from y to z is? What is the distance from y to z? I'll give you a clue. I'm kind of circling it now. What is the distance from y to z? Yeah, so you go yz equals 5 times x minus 19. So if you're looking for a place to input the 10, it'd be a good idea to put the 10 right there, so. And when you substitute, the David Cohen method says you put a parenthesis around x, then you say yz equals 5, put the parenthesis, but erase the x and put what in its place? 10, thank you. Drop the minus and the 19. And at this point, it becomes calculator work. Grab your calculator. Don't do any math in your head. Sometimes I use the calculator to do 1 plus 1. No shame. Just get the right answer. That means 5 times 10 minus what? 19. And what do I got to press in the end? Equals. So it turns out that yz equals 31. And guess what? That is the final answer. Because it answers the question, and you remember those famous 3 dots, that means final answer. It answers the question, or the task, find yz. So when you see the 3 dots, if you look at all this work, I got arrows, I got parentheses, I got boxes. But if you said, hey, Cohen, did I get the right answer? I could look at this in 2 seconds and tell you what you want me to grade. It's like saying, Cohen, this is what I want you to grade. Okay, so that, I think the difficulty level is kind of moderately low, but the complexity level is kind of high because you had to do You had to do a lot. There's a lot going on there. And you have to have the perseverance and the willingness to push through until you get to the final answer. There it is. Any questions? Okay, I'm going to ask you, please, please, please. I'm going to stop the video, or I'll probably mess this up, but I'm going to pause the video.